I am. Let's go over the one. Let's just go over the ones real quick. Hang on 1 second. Just X. Perfect. Okay. So that makes sense. Okay, I don't think I'll have any more problems. So, number 3 I put as true.
Mm-hmm.
Number 4 I put as 0.45.
Yeah.
Number 5 I put as 0.55.
Okay.
Number 6 I put as 0.143.
Yes. Seven's a total trick
Right?
question.
7th?
Yeah, the 7th.
So, I heard you guys talking about this briefly, and let's see. The combined total of 54 trials, the dogs corrected. So they were able to do it a little less than half of the time.
So that is a bit of a trick, and I put that there is little evidence, but basically, and that would probably be the best answer for probability's sake. But I mean, that would be, I mean, as it says, that's enough tries that it is unlikely for a dog to do this.
Yeah, you know what? I'm actually leaning more towards this provides strong evidence that dogs can detect bladder cancer because
Yeah.
of what it says right there. The dog, it's very unlikely that the dog would do this by random chance alone. So that's what I'm leaning towards. But what do you think?
Well, I mean, as I said, like I am torn between it because probability's sake, 22 times out of 54 times, that is less than half, so I would put less. But the or I mean, at the second sentence is basically it says it is unlikely, and I would even come up to that conclusion myself.
Well, you know
I'd have
what?
to test it again.
You know what? The probability of them guessing randomly is like 15%, and which isn't very high. But they're doing it at like 50%, so that is a lot higher. I would definitely say that 7 is this provides strong evidence that dogs can detect a bladder cancer. That's my reasoning.
Well, yeah, I mean, I guess we can put that. If we do get it wrong, we can discuss with the teacher, you know.
It might be one he leaves out because he left one out. Another problem, but sorry
Okay,
about the confusion, Veronica, of all the stuff.
It's okay.
I think we're gonna stick with this one now.
so I guess for
Okay.
number 7, we're just gonna go with the strong evidence for now. Um,
Okay.
so let's go ahead and move on. So question 8, I got, sorry, Veronica, we left off at 7, right?
No, you're fine. I caught on to what you guys were talking about. And it makes sense. So I'm good. I'm with you guys.
Well, okay. Well, I was just saying, I was about just to give the answers were 8 through 10, but of course, we stopped at after 7, so we should continue from 8. So, M&Ms are small chocolate candies. And the M&Ms website previously indicated that in the United States, the distribution of the colors in the bag of plain M&Ms is given in the following table. If you reach in a bag of plain M&Ms, what is the probability of drawing a red colored candy? And I put 0.13.
Yes.
And then for number 9, what is the probability that a randomly selected candy is green? I put 0.16. Did you guys get that?
Yeah, I got that. You just add them all up, the ones that show it, and
Yeah.
then you get 0.84. Then you subtract 0.84 from 1. That
Yeah.
gives
And
0.16.
then what is the probability that a randomly selected candy is not green? And of course, like we subtracted it from 0.16, and we got, or I got 0.84. So right now, this is where I stopped at, number 11. The ACT score or ACT score of students admitted to a medium-sized public university in the Western United States were taken from capex.com. The following summary statistics were calculated. Use the information from the public university to answer the following questions. Half of the observations are less than or equal to what number?
That would be the median, right? So 24.
Yes.
Yeah.
I think so. Good. And then 12, based on the information on the table above, the top 25% of the students scored above what number?
That would be 27?
Top 20. I think you're right.
Yeah,
20.
because for the third quartile. So 12, based on the information on the table above, the top 25% of the students scored above what number?
Yes.
Oh, wait, sorry, that was the last one. So 13, which of the following statements is not one of the three rules of probability? If the probability is high, then the probability is positive. If the probability is low, the probability is negative. I think it's
That
that,
was it.
but let's go ahead and read through the rest. The
That
summary,
one, because the probability can't be a negative, right?
huh?
Yeah.
A
Yeah, be
probability
negative.
is
Yeah.
negative.
It's false doctrine, plain and simple. So yeah.
Okay, so let's go ahead and read the rest. The sum of the probabilities in any probability is 1. That's true. A probability is a number between 0 and 1. That's true. And the probability that an outcome will not occur is is 1 minus the probability that will occur. So that's true. So I think it's the first one.
Yeah.
Mhm.
Oh, so Kevin, what I was saying that I did not get to say to you,
Mhm.
you might have heard this, but make sure when you put the decimal points that you put 0 point whatever, because sometimes online homework is specific and sometimes it just gives a range. I don't think this would be one of those.
Okay. I'm not too worried about it, but I will do that just in case.
Yeah.
Because
Okay.
0.13 and 0.13 are the same number, but we will make sure we put zeros in there just in case they're picky. Okay.
Okay.
All right. Are we good?
Yeah, I think so.
Let's
Yeah.
submit. 1, 2, 3.
Okay, and it's 100.
Sweet. Oh dear.
So I'll see you guys next week, or I'm sorry, Thursday.
I have a question about that.
Okay.
Is there any chance that we could do it tomorrow?
So my calling right now is
Tomorrow.
I'm a secretary, so I don't entirely know what those duties entail, but I think one of the meetings I have to go to is tomorrow, so I don't entirely know just yet.
Okay.
I could probably make it work.
Yeah, it's because I'm sorry, this will be the last time I ask, but I'm actually driving to Utah this weekend for a conference with my family, and we're leaving Thursday.
Mm.
Oh, okay.
That's why
Yeah.
I was wondering if we could do it Wednesday. To me, it doesn't matter how late.
Yeah, if you, yeah, let's think. Katie, what do I have tomorrow? I can't think of it right now. What do I have tomorrow? Is there anything at night? At night. I don't think so. I think I'm good. I'm good. Clayton, you might need to do it later, but.
Check the text real quick that I received. So I think my meeting is at 6, but I don't know how long it runs. But yeah, I'll get the details on that, see if I really do have to go or not, or how long it'll run for. This is also like some dinner thing, I think. So, hopefully I won't have to go to it, and if I do, hopefully it won't run that long. And, I'll let you guys know tomorrow.
So should we plan on like 9 o'clock or something? And then if it changes, Clayton, you can text us or something like that.
I guess for now that would be a safe, time.
Okay,
Okay.
cool.
Okay, if not, then I'll try to see what I can do. Maybe I could like pull over or something on the way.
We'll see. I don't know if that would. I mean, you have to find a place that gives you free Wi-Fi.
Well, oh wait, do you guys have Denny's? I don't know. We have
Yeah,
Denny's.
we
They
have
all have
Denny's.
free Wi-Fi.
We have Denny's. Yeah.
Oh, okay. So I'll make it work. But if possible, if it'd be okay, we could do it
Yeah.
tomorrow.
We'll plan on 9 o'clock. Yeah, tomorrow. And then if it needs to be pushed back, or Clayton, even if you can meet earlier, that'd be great too.
Yeah, I'll let you know what goes on. I
Cool.
also
Send us
see
a
how
text.
long I need to study for and how long the homework runs for. I'm sure the homework can, I'm sure he doesn't mind as much about the homework, uh, as long as we study most of it and we discuss it, like whether we do it or not. Of course, I will try to do it. So I'll see how, I mean, how
Okay.
much we have to study and all that, and you know, um, well, I'll just try to figure out how much time I might need, um, like if it'll work.
Sounds
Okay.
good.
Sounds
All right.
good.
We'll see you guys
Thank you
tomorrow.
guys.
Okay,
Okay.
bye.
Bye bye
Bye.
now.